Good afternoon, everyone. So your last half of the last day. So you've hopefully you've been learning a whole lot of stuff. Hopefully you'll learn much more in the next 40 minutes. We're going to be talking about messaging patterns. Now, sure enough, it doesn't matter what cloud you're using. So Azure, GCP, AWS, these patterns are applied to whatever cloud you're using. Or I say cloud architecture, this also works locally. So if you're using things like RabbitMQ or what have you. But I definitely want to talk about the different message patterns because everyone thinks that, when we talk about messaging, everyone thinks about the pub sub, and I will talk about pub sub, but there's a lot of different other options, when we need to solve other problems. So first off, to start off with some fundamentals, why do we care about messaging systems? Why bother with them? Well, first off is providing that seamless communication, having ways to easily communicate between different services, and more importantly, in a disconnected way, right? So I'm not directly calling upon either. So I'm I'm getting that decoupling going on. Also being able to do things like diverse technologies. So for example, where I work, we have a lot of legacy work that is sitting on-prem, and that legacy is a range of technologies. From something called Visual Data Flex, which anyone's ever heard of Visual Data Flex? I'm waiting for the day I finally meet someone who's actually heard of this thing before. I had never heard of it before I joined the company. But also ASP.NET and so forth. So lots of different technologies that we're trying to mix in with new technology. So that's where messaging patterns really help out with a lot, or messaging systems. But also providing that scalability and that durability. How often do we have to have these APIs that can't keep up, right? Whereas messaging systems provide that buffer and allow for the consumer to react as needed be. And then finally, reliability and fault tolerance. One of the big reasons why I got into event-driven architecture was I was trying to build systems that I could have a service go down, but the rest of the system could keep on going. It keep on sending its messages and do what it needed to do. And that's the things that we get with messaging systems. So, so if we go into messaging patterns, so what are we talking about? Well, pretty much just like a regular pattern, right? The idea that we have these reliable, scalable communications, and that we have, again, decoupling components. That's where messaging really plays into it. And, one day I went and looked for, every messaging pattern I could find. And there's probably more. I mean, this is just in a couple hours search, but there's a lot, right? And and we're going to focus on quite a bit of them today. But these are the ones, and don't worry, it's really small. That's kind of the point. It's that there's so many different patterns. But why are these patterns important? Just like with regular patterns, so we can improve our reliability. We have that better efficiency because we see patterns that have already worked before. And and more importantly, to handle those real-world challenges. And part of the whole idea of this talk was, again, like I said, most people understand the pub sub, but there's a lot of other things, when different situations come into play. So let's get into it. So and start off with, the most obvious, the point-to-point messaging, right? The whole idea that I need to send a message from one receiver or from one sender to one receiver. And, again, this is the most straightforward, right? So if we look at it, a couple key components, you have the producer or the sender, you have the queue, and then you have the receiver. So graphically, it looks like this. So, the producer says, hey, I have something that I need someone to know about. So it'll send it over to the queue. And again, whether it's a queue or a topic doesn't matter. It's just a point. It's some type of queuing system. And then the consumer says, I'm ready to receive that message, receives the message, does whatever they need, right? And that's the process. So very simple, very straightforward. Lots of benefits. This is simple. It's decoupling. But some of the other big benefits here that we don't normally think about is like that guaranteed delivery. Compare this to just like an API call. So an API call, I don't have a guaranteed of that delivery, right? That message goes out, and yes, I'll probably get a status message, but it's not really the exact same thing. Whereas within, when I'm putting a queue in there, most queuing systems, guarantee that there's delivery. Now, there's a little bit of a misnomer there. Guaranteed delivery to the queuing system. right? What happens after that is up to the consumers. They're supposed to read that. So lots of benefits. There are drawbacks. And really, this could pretty much be said of a lot of things within messaging. Number one, latency in the middle. That's messaging 101, right? Just the fact that you're sending a message and you're waiting for someone to pick it up, there's latency. Now, usually when I have architectural discussions and people are like, oh, well, introducing that is going to produce latency. I'm like, are we really worried about like the 10 milliseconds it's going to take for that message to come across the wire? All right, because usually it's really, really quick. But, the one big one when we talk about this pattern is we have that single point of failure, right? It's just a queue. It's just because of its simplicity, you do have to consider that. Of course, use cases, your job queues, your task scheduling, your order processing, things that are going to go through a simple process. Now, I said we would talk about the pub sub or publish subscribe. And again, this is what people are normally thinking about when they think about messaging and doing event-driven architecture. And sure enough, 90+% of the things you do in event-driven architecture is using this model. And here we're talking about, again, we're going to publish this to a topic for multiple subscribers. And, and again, having that, flexible communication. I generally get the question, well, what's the difference between a queue and a topic? They're really the same thing. It's just, pretty much basically a queue is meant for one receiver, whereas a topic is meant for multiple receivers. And basically, and we'll see the next slide, you're basically creating multiple queues for each one of those consumers. So if we look at our components, again, we'll have that publisher. So the component that is actually doing something, it will have a topic, and then you'll have subscriptions. So each consumer that is getting messages from this topic has their own subscription. So it has its own checkpointing, and so it's getting the next message that it hasn't received yet, not just the next message total. And then you'll have your subscribers. And again, you could do this with just one subscriber. It's not like you have to have multiples. That's the other thing. Generally, when people ask me whether to use a topic or a queue, my thought is if you know you need multiples, obviously you want to use a topic. If you ever think you're going to have a second consumer, then go ahead and do a topic. All right. But so visually, and then you have your broker. So the publisher generates that message, sends it off to the topic. The topic then says, okay, I have these subscribers, so I'll send those messages over there. And then the subscribers will then pick them up on their own. Doesn't really show it here because everything's just sequential on here, but actually those consumers can grab them on their own at your rate. Because maybe one consumer is reading a whole lot faster than the other, and so forth. So your benefits, here, again, that decoupling, right? Because now I've got a decoupling, and more importantly, I can have multiple consumers. Think about the learning systems, or think about like inventory systems. There are multiple people need to know something happened, right? And that's where you really get some use with this. And again, that scalability, flexibility. There are some drawbacks. Some of these really do depend on the brokers you're using and so forth. Most cloud brokers, scalability is not really an issue until, I've got friends who design systems for multinational banks where they're doing millions of transactions a second. They have to worry about scalability. Most of us don't have to worry about that. There is a subscriber dependency, so it's not just the fact I sent a message to the topic. If no one subscribed to it, then no one's going to pick that up, right? So there's a bit of those dependencies. Error handling is a bit of a drawback because it's not straightforward. Well, we'll talk about that in a moment. There's a pattern that handles that. As far as your use cases, so again, that broadcasting events, the way I always describe it is, hey, I just did something. I bet you someone needs to know about it. So you're broadcasting out. Real-time feeds, it's used quite a bit for that type of purpose. Several years ago, I was working for an education company. We had students all over the world who were taking these practice tests, and we needed to do real-time reporting or real-time grading of the practice test. And that's exactly how we did it. We were feeding into a pub sub, and then other technologies to do all the scaling, but worked really well. Alert system, another perfect example of this. All right, so this one, the competing consumers, Honestly, most people don't even realize they're doing competing consumers and they're doing competing consumers. And this is really more of a bolt-on. Several of these patterns we're going to see are really add-ons to other patterns. And this idea, I'm going to have multiple consumers read and process a queue, all right? So basically, what happens when I need a lot of work done? Well, don't just have one thing do it, have multiple things do it, right? And the reason why I say most people don't even realize they're doing this is like if, for example, let's say you're using, in Azure, you're using Service Bus and then you're using Azure Functions, right? Or in AWS, you're using SQS, or I always forget if it's SQS or SNS, and then Lambdas, right? But the point is those are actually creating competing consumers because they're having multiple functions read those messages so they can process them quicker. So graphically, we're looking, we've got the producer, we've got the message queue, message topic, what have you, and then your competing consumers. And here, this is quite simple, right? And of course, the broker. So here, the producer, sends a message, and then, the first consumer will pick that up. And we'll start doing work, as will the second consumer, and maybe multiple consumers, all depending on what you're doing. And again, these will keep on reading as they go, and then process the message so they can clear it through the queue even quicker. Like I say, mostly you'll do this with functions or lambdas, but also you can just write them your own and just have multiple editors. So it's really nice. So again, your benefits, big one is that scalability and that load balancing. But another one we don't normally think about is fault tolerance. Because, messages don't always come out clean, right? We get things that get things trapped. Maybe it's maybe it just takes longer to process it. Maybe it's got errors and it causes faults on that consumer. Well, the nice part here is I don't just have one consumer reading it. I have multiple consumers. So if one consumer goes down or is stuck for a while, I can still process more messages. Your drawbacks, messaging order is a big deal here, all right? So I now have multiple consumers getting them. They're not necessarily going to process the messages in order. And so that's something you do have to think about. Of course, now in general, when it comes to messaging and order, I always ask the customer several different times, does messaging or order actually matter? Right? Because, of course, always the first answer is, well, of course it matters. And I'm like, but does it really matter? Right? Because there's things we have to do. And there's actually a pattern that will handle that. Coordination can be an issue, right? If you actually need to coordinate this, then this might not be the right pattern for you. And then, resource contention, because again, if you have multiple instances on one machine, you're running all those yourself. You have to think about that. Task processing, data processing, order processing, these processing type tasks where there's a lot of things coming in. That's where you will normally see this. All right, the next one, again, another add-on is filtering. So the idea here, what happens when I don't want everything, right? I actually need to filter those messages out. Or it could be problematic messages. So, sometimes these aren't even what you necessarily think about. So the big system we're working on right now is basically our new ERP system. We need a custom ERP. We're unique enough. But we're actually doing it in phases. So we're not going to bring in all the manufacturing units all together. But the other system that's going to feed us all what we call the production orders, so basically the sales orders, it's going to feed us everything. And so we're actually going to filter them, right? We're going to say, okay, we only want the messages for these or manufacturing units. So that's a perfect example of where you would use this. So in here, we pretty much see it just like we've seen before, topics, descriptions, but the important part is that message router. So in here, the producer will send it off to the topic. The router gets that. Let's notice that blue. You can hardly ever see that. But in here it's reading, oh, that's description A. So it'll send the message over to description A, right? Oh, this is a description B, so it sends it over there. And then you have different consumers they're responding to these. And again, this can be that, some of those messages never get picked up, right? That they just get dropped, and that's fine. All right. With that being said, you actually need to know about that so you can handle that, because otherwise you're going to get messages expiring, and that might cause other issues. But pattern-wise, it works just fine. So your benefits, efficiency, because I can get just what I need to get, right? And I can get flexibility with this because now, again, like I say, maybe I don't care about all the messages. I care about these particular messages, right? Maybe I care only about the messages that are for this branch or for, this condition, that type of thing. Complexity is one of the biggest drawbacks here is because now, you've got to write the filters and so forth. Most of the brokers have actually done a really good job. In Service Bus, the one I use mostly, it's basically a SQL-like syntax, so it's pretty easy to write. But there are things you have to think about there. Again, your use cases, think about that subscription filtering, data segmentation, notification systems are a perfect example, right? I only want the high priority alerts type thing. Now, message routing goes right hand in hand with filtering. They're very, very similar. Here, but the idea of I want to direct messages to different queues, right? So the message comes in and actually gets, rerouted. And a perfect example is like problematic messages. So in here, again, you'll have your producer, you'll have your consumers, you'll have your multiple queues. So the producer sends a message over to the router, and the router reads that and it says, oh, that is for endpoint A. So it sends it over to endpoint A. The next message comes in, it's endpoint B. So it sends it over to endpoint B, right? And so that's basically what we can see in here. Probably a better example of this is like high priority, low priorities. Here it's going to the same consumer, right? So, the producer sends this over, oh, this is a low priority, goes in low priority. Nothing was else in there, so it just picked up that one message. But we see more messages coming in. The consumer finishes that one low priority, and it says, okay, I'm going to first check the high priority queue first. Pick that message up, and then process the other messages in low priority, right? That's a perfect example of using the routing. So again, flexibility, scalability, improve organization is big benefit here. I think the complexity is the biggest one here, especially like if you look at that second example. I now have the consumer needs to know about multiple queues and needs to have the logic to say, okay, let me go check that this queue is empty or not. So there is definitely some additional complexity in there. But load balancing is a perfect example, content-based routing or priority routing. All right, who in here writes code that never fails, all right? Well, since most of us don't fall, well, one person raised his hand, I don't believe you. But how do we handle when things go wrong, right? And that's what dead letter queues are all about. So basically these are to handle, it's a secondary queue, right? So it's just basically add another queue, and it's for those messages that have problems. So, here, we see the regular queuing, right? The broker, the message queue, again, topic, what have you. The producer sends a message over, it goes to the consumer, and here we see everything works. So that's great. Well, we get more messages coming in here, and at some point, a message comes in, and the consumer has a problem with it. And what the problem is could be a lot of different things. It could be that it's a malformed message. It could be out of range. It could be expired, right? Hey, you're supposed to send this message, but you sent that a day ago. It's too late for us to respond to this. But whatever that might be, basically what happens is, generally the way how the SDKs work is you just basically say send this to the dead letter queue. So that's literally what happens is it goes to the dead letter queue, and the consumer then can continue on. Right, it can process all the other messages just like normal. Now, what the pattern doesn't talk about is what do you do once it's in the dead letter queue, all right? And that's where, and again, it's going to depend, right? I'll use my typical architect's answer. A lot of times we'll set up alerts to look at things when they go in the dead letter queue, because sometimes it's just a matter of it just needs to be resubmitted, all right? Sometimes we can use some logic and say, oh, they submitted over here, but we know we can change that value, right? It depends on the business rules. But the big thing is you do want to look at that the dead letter queue. And that's one of the hard parts. The dead letter queue can become, that crying wolf. I don't know how well in Europe that's understood. The boy who cried wolf, keeps on crying wolf. Well, that's what happens. We see a lot of messages go in the dead letter queue because of stupid reasons, and we say, oh, we can ignore those until the ones that get in there that cause problems. So that's one of the hard parts with this thing. So benefits, providing reliability, right? I now have a way that I'm not just throwing away the messages, I'm actually sending them somewhere so I can do research on them. I can look at that. I can do troubleshooting, and I can add efficiency. Drawbacks. And notice I put a question mark where is there ever really a drawback when I'm doing error handling, right? But if we were to look at drawbacks, keeping with the way how I built these slides, the biggest thing is complexity, right? Because now I need to figure out what I'm going to do with those messages in there. And technically, delayed processing is a drawback, right? Because obviously, the message that went in there isn't getting processed in the normal flow. Your use cases, it's pretty much, you should almost always be using this, right? Unless you really don't care what happens. And sure enough, there can be use cases for that. But generally, you're going to use this pretty much everywhere else. Message expire is another one that we don't normally think about. But again, sometimes messages do need a process within a period of time, and you'll expire them. And that's usually the one that we get caught up the most with because we don't even notice that they were sitting in that queue for a long period of time. All right, getting back to less bolt-ons, and now how do we solve other types of problems? And that's what the next series of patterns are. And the next one being the sequence convoy pattern. So I talked about message ordering, how that matters. That's what the sequence convoy is all about, right? How do we handle messages that need to be processed in order? Because like I say, generally messaging does not care about order. It's just whatever gets processed first. But here we're actually going to enforce that. And here we'll have, sorry, I clicked too quick. So we'll have three different things. You have your queue itself, right? You have your order key. So basically, what is the ID that's going to tell me that this is a group of messages? And then you'll have your sequential processor, and that's generally your message broker is handling that, right? So basically, I got all these 5 messages. They came in this order, and they had that order key of 1, 2, 3, 4, right? But these other 6 messages had 1, 2, 5, 6, right? So that they send them over that way. So we see this come in here. The producer produces the message. You see the A comes in. The consumer just picks up A because there was nothing else in the queue. B message comes in, but in the meantime, another A message comes in. So the consumer is going to say, "Oh, I'm already working on the A, so I'm going to pick up another A message," right? And then it will finish all the A's before it picks up that B. Now, in reality, that's not the way how we actually do this, because we mix in competing consumers, and then we basically have each competing consumer that's picking up each different order key and running off of those. And again, Azure Functions makes it very, very simple. You literally say supports sessioning, and if I remember, that's all you do. It makes it very simple to do that. So your benefits, data integrity. Right, because again, when order matters, right, it matters because of keeping that data, keeping it consistent, keeping it reliable. Your drawbacks, the biggest one can be that complexity, because now you're having additional handling of the orders, and then the other two are very much related. Reduced throughput and potential latency. Number one, if you look at just the way how the pattern's written, by default you're going to have latency because that B message didn't get processed until all the A's got processed. So this can happen even in competing consumers because, again, if you have a whole lot of groups, eventually, like if you're using Azure Functions or AWS Lambdas, they're only going to scale so far, right? And then they're going to stop scaling up. Use cases, order process, event sourcing is a perfect example of using this. When you need to, when you're using event sourcing and the source of that data is coming from the messaging, then you definitely want to be using this pattern, right? Because otherwise, you're not doing event sourcing, right? So perfect examples of using this. Next one I'd like to talk about is the request reply. So basically, what happens when, so messaging by nature is asynchronous, right? I send the message out and it just happens, right? It's a black box, right? And, I keep on going. What happens when I need a response, right? I actually need to know what happened. And that's what this is all about. How can we do this? So the request is actually waiting for a reply, but I'm doing this still with, that asynchronous way, right? I'm still sending a message off to a queue, handling it that way. And that's what we're talking about here. So in here, you'll have your requester, ties to a request queue. And then the responder, right, or server is actually the way how the pattern's written up, receives that message, and then it'll have a response queue, right? So the request will send the message over the queue. And then basically what's part of in that message is saying, hey, when you're done, send your response. Tell me what you did to this queue. So you actually are directing it to where it's supposed to go. So it does its thing. It sends, and it'll send the message to where it was told to send the message off to. And then the requester can then pick that back up and do whatever they need to do. It's a really nice pattern. One of the ways how we're using it, so I talked about we're doing all these legacy systems. While those legacy systems, one of the things we don't want to do, because our goal is to get rid of all the legacy systems. We know that's about a 10-year picture, right? Just because there's so much. But one of the things we're trying to avoid is writing new stuff in there. So we're actually, sending message off in this manner. We're having a function pick that up. It sends it over to the queue, and then sends back this way. But the nice part is when we do move that down, and it's now out in the cloud, we've taken out a legacy and we've rebuilt it in the cloud, we can use the same pattern, right? I don't have to change anything. And so the other system's already been written, doesn't change. So lots of good benefits, especially simplified workflows, right? That's a perfect example using this. That example I was just giving where, we're sending things off to legacy. That's a workflow in itself. But also getting that reliability, control and coordination. A couple different drawbacks. Complexity is an obvious drawback. Single point of failure I think is the biggest drawback here. Because now, like I say, I'm waiting for that thing to happen, right? And if it doesn't come back to that response queue, then, what happens, right? And normally you time out, right? You'll say, I expect this answer usually comes within, 20 seconds. If I don't get the response in 20 seconds, we'll time out or what have you, right? And actually, if it's your normal 20 seconds, I say you do 25 or 30 seconds, right? Give it a buffer. Use cases, biggest one is service invocations, right? Where you're going to invoke another service and you are expecting a response. Data retrieval status updates are another great examples of these. As a matter of fact, if you were in my durable functions, I talked about the HP async. That's basically an implementation of this pattern, technically. There's the next one. So what happens when I need to get results from multiple services, all right? So that's what scatter gather is all about. And if anything else, I just love saying scatter gather, right? And I love being in a meeting and saying, well, I'm going to use the scatter gather pattern. But the idea is I'm going to send this out to multiple recipients, and I'm going to aggregate the value back. All right, so one example of how we use this. So we're a US-based company. We actually do all our own shipping across the country. We have branches, we have 52 branches across the United States. But what we don't do is ship into Canada. So, but we do have customers in Canada. So what we do is we actually ship our product to the closest branch we have, and then we use a common carrier to get it across Canada. And so what we'll do is we actually have a service where we send out requests to all these common carriers. Hey, here's what we need to be shipped. So tell me what your rate is, and then I can compare those prices and pick which one's the best one. So that's basically what we're using this pattern, right? So here, you're going to have the requester, so the thing, hey, I need some information. You're going to have the recipients, and then you have the gatherer. So basically what we see is here, the requester, like I say, will send the message off to however many recipients there are. Those recipients will pick up those messages, do what they need to do with it, and then send it, when they're done, very much like the request reply, they'll send a message off to the gatherer queue. And then there's a consumer listening to that gatherer, picking up the messages, producing its aggregate value, and then sending that response back. Now, one thing you generally will do within here is you will time out, right? Because sometimes those requesters can't respond fast enough for one reason or another, and obviously you don't necessarily want to wait forever, right? So sure enough, I mean, like that one example I was giving, I mean, it's set to timeout after 50 seconds, right? Because our guarantees, we were guaranteed a response within a minute, right? So that's why we do things like that. And unfortunately, a lot of those APIs are, I don't know why the carriers are so slow to turn a rate request. So some benefits, efficiency, right? I now have an easy way to send messages off to multiple users or multiple systems and get a response back. I get scalability, I get resilience because I have a way to handle this, right? Complexity and latency are the two biggest ones that we have to deal with, right? And again, like I was just saying, a lot of times we'll have timeouts, so we make sure that, and we'll just, we literally will return back in the response. We didn't get a response back, right? And that's how we return it back. Parallel process is the big one. Data aggregation, load balancing. These are examples of when you use this. All right, the last pattern I have in here is the saga pattern. So, in messaging, transactions are a complete pain. And, Service Bus and AWS stuff, and, they all promise that they have transactions. And I refuse to use them because they don't work, right? Or you do so much work to make it work, it wasn't worth it. But there's the saga pattern. And here's the thing, the saga pattern is not just a messaging pattern. I mean, this is actually in the Gang of Four book, right? So it's a very known pattern, but it works very well in messaging. So the idea here is we're going to break a process into transactions. Each one of those is going to be smaller steps, and and they're all going to be independent. And so we can now have a good way to manage these long-running transactions. So visually, first up you have your saga coordinator, right? So this is the thing that's actually going to orchestrate that work. It's going to say, okay, it knows all the steps that need to happen. And it knows the order they're supposed to happen in, and it actually is maintaining this. You have your transaction steps, which generally are just queues that we're sending messages off so that a consumer can pick those up. The other big thing is you'll have your compensating actions, and this is where this becomes transaction-based. So if something happened on step 3 of 8 steps, how do we roll back, right, those previous steps? The compensating action is also one of the hardest part here. And then finally, state management, because now you need something that's actually managing all this. So if we look at this, the saga coordinator gets in a request, hey, here's what I needed to do. So it literally would send it off to the first step. That consumer will pick that message up, do what he needs to do with it, and basically sends it over to a queue that the saga coordinator is listening to. Saga coordinator picks up that message, says, okay, great. Step 1 is done. It was successful. I can now go on to step 2. So it'll send the message off to step 2's queue, and then this process will continue. Now, what I don't show in here, because there's only so much I could put into a PowerPoint slide, is what happens when something goes wrong, right? So again, if we're on the second step and it failed, or we're on the third step and it failed, basically what happens is the saga coordinator then does what it knows to do to step this back, right? And and whatever that might be. It might be sending another message off to another queue. It might actually be manipulating data. And again, that's going to depend on what your needs are. Fault tolerance, data consistency, scalability, right? Because now I can actually break this apart. I can do smaller steps into here. Complexity is the obvious, right? I mean, now I've got all these things that are happening, lots of different queues, lots of different consumers. But then, the middle one, you're talking about complexity, compensating logic. I now need to know how to back those things out, right? And, so that's why I do recommend, you write these, those steps very small so that, so they are making smaller amounts of changes each step. And latency is the obvious, because here you're doing, because you're having multiple things happen, and they are happening sequentially, right? So latency can become an issue. Now, with that being said, the pattern is written that it's basically sequential. You do step 1 and you wait for step 1 to finish. maybe there's a situation where you're going to fan that out actually as part of that step one. That's also a possibility. Just depends on your needs. Microservice is a perfect example of using this. We use this, so we're microservice based, and so we use this quite a bit for that whole purpose. Again, how do I handle transactions, in a messaging system? Order processing, travel booking. A lot of times when you actually book, like an airfare, they're actually using a Saga pattern because they're looking, because when you get to the purchase screen, that seat's actually not even reserved for you. It's only sort of reserved for you. And they're actually doing those steps. And then what happens with, they actually sold it to someone else, right? Or another system sold it at the same time, right? So with that, we spend the last almost 40 minutes talking about all these different patterns. Like I say, lots of different patterns to help with different needs, right? And a big reason why I wanted to do this talk was to show, when we have different needs, there are different ways to do things. Now, with that being said, what I don't encourage you is to say, I've got to need to find a reason to use each one of these patterns, right? Because, use the right patterns. So quick little funny story. I also do so this is my 40-minute version of this. I have an hour-long version. I also have an all-day version where we actually do these patterns. And I gave that earlier this year. And this kid, he was, 2 months out of university. And he's like, hey, can we talk afterwards? I'm, sure. And he's like, all right. And he was showing me the side project he was working on. It was a really neat project. And at the end, he's like, so which messaging patterns do I need to use in this? And I said, none. And I was like, there's nothing in here you need a message for, right? Everything should be sequential, right? But with that, any questions? Well, awesome. So sure enough, there's all my contact information. Definitely, if you have questions afterwards, feel free to reach out. The QR code will take you to the repo for this presentation. I normally don't actually give out my actual presentation decks. This one I did, right? Because I actually put a lot of notes into there to better explain all the patterns. And also I have code examples for most of these patterns, so you can actually see this. They are meant for their C# and their service bus, but even if you're not using service bus, you can actually understand the patterns pretty well. Because I don't use Azure Functions and so forth. I'm actually using straight C code purposely so that anyone could actually understand them. So with that, thank you so much, and I hope you had a great time here, and I hope you have a great rest of your day here. Thanks, everybody.